Hi everybody, James again from RCR Wireless. Welcome to this presentation session with Druid Software, and I'm really excited about this one, maybe more than anything else today, if that's not too much pressure, David, because it is about TSN, time-sensitive networking, which has been talked about for donkey's years since the 5G spec was created in 3GPP, and it became clear that 5G was not being made for consumers and smartphones, but for enterprises, and not just for enterprises, but for kind of hard-nosed industrial enterprises doing industrial automation in factories and plants and everywhere else. And then all the talk about TSN, even the talk about URLC really went quiet and nothing until now, maybe. So I'm delighted to introduce David O'Byrne, who is Business Development Manager at Druid Software, who can revive this conversation, David, and this big and important topic, and tell us exactly where we're up to with TSN on private 5G. So, David, thanks for joining, and I'm really looking forward to this one.
My pleasure, and yeah, thanks for building it up so heavily.
And just a reminder, David, before you start, just a reminder to everybody, we're open for questions after the presentation, so please ask them as we go. But yeah, David, sorry, it's over to you. The floor is yours.
Thanks very much, James. Before I start, Druid Software, for those of you who don't know, please check out our website or our LinkedIn presence. We are a company based in Dublin, in Ireland. We have been in the private network space for 15 years, which would make us one of the pioneers of cores in private cellular all the way back to 2G days. And we have remained at the cutting edge of private cellular network technology ever since. So we're delighted to be maintaining that role as 5G finally starts to deliver on the promise of cellular networks for industry. What I'm going to do is start off by taking us through the landscape a little bit, and then describing the roadmap of how we get from where we are now to 5G LAN, and then into time-sensitive networking over 5G. So a little bit of background, despite 5G having been in many ways built for Industry 4.0, with a lot of industry representatives joining the ETSI folks down in Sophia Antipolis in the development of the specification, with the introduction of network slicing and the introduction of special features like James mentioned of URLLC, but also the EMBB, the massive machine type communication, and the promise of 1 million devices over a square kilometer capacity being the key requirement. We would have to say that compared to the heady days of 2018 and 2019, when Harvard published a forecast of millions of factories and warehouses, adoption to date has somewhat underdelivered. The figure of 359 industrial networks comes from the GSM Suppliers Association. In total, they're tracking several thousand networks, but industrial networks, manufacturing networks, is the biggest of those segments, but still is under 500 networks. Now, they're not looking at Chinese networks. They're only looking at networks from some vendors. And for full disclosure, Druid is not one of the vendors that's adding its deployments into that number. But as an objective, publicly sourced number, that's what we have. And it's obviously orders of magnitude away from the end game that we expected. Now, to be fair to all of us, we have had 2 doses of Donald Trump, a dose of COVID, the war in the Ukraine, energy prices, tariffs, the massive inflation. We have had some fairly serious macroeconomic headwinds over the last 5 or 6 years. But our thesis is that that is not the only reason, or even the main reason, why industrial companies have been slow to move away from their wired OT networks or their Wi-Fi networks and start to adopt cellular, even though cellular has all of the advantage of better security, better reach, better throughput, etc. We reckon that the main driver for it goes all the way back to the OSI model, where 5G and all other IP communication happens at layer 3, and for eons, industrial OT happens at layer 2, so it's Ethernet communication. These are kind of fundamentally different. How are they fundamentally different? In practically every way. from the kinds of devices that are involved in the network. Instead of talking about internet routers and PCs and smartphones and servers, in layer 2, you're talking about SCADA systems, you're talking about PLCs, switches, sensors, gauges. Instead of doing the dynamic routing using protocols like IP or OSPF or BGP, which are designed to move the packet as efficiently from A to B as possible without worrying too much about the jitter, the difference in the time it takes from the first to the second packet, or even the order in which the packets arrive. Over in layer 2, it's a point-to-point system that is very much built around consistency and uses Ethernet protocols like Profinet and OPC-UA, also EtherCAT, other industrial communications standards. And that means that in layer 3, you're achieving really low latency because the system is picking the best route for the packet from A to B every single time. But in layer 2, you're going point to point. You're also as concerned with consistency, with having low jitter. If you play video games, you'll know what jitter is. It's the way sometimes the play action gets a bit bursty. It can go faster or slower than you're expecting it to go. So it can be too fast or it can be lagging, but it's not consistent. And that's what we call jitter. So the first step to delivering time-sensitive networks over 5G is what we call 5G LAN. It's also known as Ethernet PDU, but the marketing folks took a look at Ethernet PDU, decided it sounded like a dessert, and decided to call it 5G LAN instead. And what 5G LAN does is basically you're enabling the transmission of the Ethernet frames directly over the 5G network. What industry has done up to recently to try and fake out layer 2 over 5G is it's taken each Ethernet frame, it's wrapped it up in an IP packet, it's then had a local NAT table to tell it what IP address to send that packet to, sent it across, and then at the far side, it takes it out of the IP packet, looks at another NAT table and says, yeah, that's going to MAC address 12345, whatever. This is obviously really slow because in a lot of cases you're leaving multiple ports open on routers so that you can say, I know that every packet coming in on that port is going to that MAC address. That's great. That speeds it up a little bit, but it means you're leaving loads of ports open in a world where, to be honest, you would like to be shutting down ports as much as you possibly could. And you have to maintain all of these network address translation tables. So this way of faking it out using tunneling or VXLAN, it doesn't really deliver at at industrial scale. What 5G LAN does is it allows you to send that Ethernet frame directly over the 5G network without encapsulating it in IT packet. You have no network address translation tables, and you have bounded jitter, which means you know roughly how long it's going to take that packet to get across. So why is that a game changer? Well, there's a lot of benefits from that in its own right. You have that industrial automation requirement for ultra low latency that you're now meeting. You have the much simpler installation of any 5G connected device because you don't need to do this encapsulation. You don't need this NAT transversal. You can take advantage of the same simplicity of deploying any Ethernet device. You have a nice flat network topology. When you install your devices, you're using the same device discovery and automatic configuration that you would with any Ethernet device. It simplifies your maintenance of the network. It simplifies adding devices or taking devices away from the network. And you're able to take advantage of layer 2 security. So you're able to use MACsec instead of IP address sec. The MAC address, if for anyone who's not familiar with it, is the unique identifier that every switch, valve, everything in the industrial internet has. And that's the security built around that is far more secure than IPsec. And you've got more granular control over the traffic within the network. So 5G LAN in and of itself is a really good thing. We're demonstrating that today in the Brainport facility in Eindhoven, in KPN's lab there. And there's a lot of industrial manufacturing companies that are excited just that we're bringing 5G LAN to the table. But where we're really excited in 5G LAN is because it is a prerequisite for time-sensitive networking, or TSN. So why does anybody care about TSN? What TSN brings additionally to what 5G LAN gives you is it gives you this precise time synchronization, and we're talking about to microseconds across the network, and it's synchronizing every device in the network. So PLCs, robots, autonomous robots, AGVs, drones, especially robots where people are working with them, because you need this microsecond ability to stop in case somebody walks into their range and they're in danger of being hurt by them. So the vision that we all have of the factory of the future, where it might be dark because there's no need for people in there. You've got drones and AMRs flying around the place, carrying material from station to station. The automation is able to move at a much faster cycle time because there's no people there in the process slowing things down, or very few. To deliver this kind of experience, that's what you really need the time-sensitive networking for. Time-sensitive networking has been around for over 10 years. It was originally developed as a standard by IEEE back in 2012 or 2013. It's only fairly recently been widely deployed in the wired network. So it's really quite exciting that 5G for industry is able to catch up that quickly and start to put time-sensitive networking over 5G into the industrial domain. And how are we actually doing that? Well, what TSN means is somewhere in the industrial network, you have this thing called a TSN Grandmaster. You can see it there on the right. I'm not sure if you can see my cursor. And that is basically the master clock, and it's synchronized with GNSS and satellites in space and so on. So that is creating a millisecond accurate single source of time for all the devices in the network. And what each device in the network does is it passes a time synchronization frame along each device in the network. So whether it's wired or wireless, everything is getting the same single source of time. The elements involved in that are the Grandmaster will talk to the network TSN translator, NWTT, which will bring that time sync frame then into the core network, bring it out over the UPF, out to the G node B, and it's then sent out to any connected device in the network, where it goes to the device side TSN translator, or the DSTT, which can take that package and it can synchronize that time frame with the device that's connected to it, be it a robot, be it a camera, be it a PLC, be it anything. But it can also then pass on that same time frame into wired elements of the networks that are, let's say, downstream from it. And in this way, even without having a wire running from one end of the network back to the Grandmaster clock, you can create this microsecond accurate time synchronization across every single device in the network, be it wired or wireless. Now, what do you need to actually do on the 5G side to deliver on that kind of a picture? There's probably three main elements that need to be delivered to do that. First of all, you have your network side TSN translator element. Then you also have a TSN application function, and that is basically what you're doing is you're looking at the cellular part of the network, the wireless part of the network, as just another Ethernet leg, the exact same as it is over a cabled part of the network. So each one of the wired parts of the network in TSN is communicating back to a thing called the centralized network configuration and the centralized user configuration. And this is the part of the system that knows the latency that each individual block in the system will have, and it determines the prioritization and the timing for packets going across the entire TSN network. So all of the wired elements have got the ability to talk to that network. Your wireless network, your 5G network, also needs this thing called the TSN application function, so that it too can talk back to the CNC. And then on the device side, you need the device side TSN translator. Now, that is not something that Druid is doing. That's something that we are partnering with Analog Devices to do. We are focusing on what's in our little block there, which is the TSN application function and the network TSN translator. We've been working with Analog on this for quite a long time, and we now expect to be, by the end of Q1, we'd love to be able to have it for Mobile World Congress, but let's be a little bit conservative and say the end of Q1. We expect to be able to show a full end-to-end wired and wireless TSN network for industrial automation in conjunction with Analog Devices. And this will be built at the Analog Catalyst Lab in Limerick. I'm going to swap over to a little video here just to tell you a little bit more about it. Am I doing that right? Hopefully.
David, I'm just going to come in before you talk over this and just say we've got a couple of minutes just to keep you.
Yeah, I see that. I'm looking. Analog have been in Limerick in Ireland, which is where the Catalyst Lab is, for 50 years. They employ a couple of thousand people there. And if you're not that familiar with Analog, they convert every kind of sense, be it temperature, pressure, mass, everything like that, into electronic signals and supply not only the industrial automation world, but the healthcare, the defense world, automotive, aeronautics, all of those kinds of verticals use Analog Device technology in their end devices. I'll just cut through to the end of this. In the lab here, we're using Siemens Profinet routers as a demonstrator, but obviously the plan is that it's open standard and will work with anything. And I think I'll stop it there and see if we have any time for questions. Although,
so David, I'll just come back in because we only got a minute. But there's a question around availability and roadmap, and you said 5G LAN today is being demoed, wireless TSN next year. Just when does this become a commercial proposition?
It's an ecosystem play. So Analog Devices have to create the semiconductors for it, and then individual device vendors have to build that in. But I expect that we'll see 5G LAN devices very commonly this year. In 2026, and by the end of 2026, we'll be seeing TSN wireless capable devices on the market.
Okay, that's great. And there's another question here about GNS jamming. Is that something you want to take a swing at?
Yeah, look, it's a massive issue for almost every area of commerce, particularly aeronautics, but lots of other places as well. It's a little out of our wheelhouse. We need to depend on the partners that do the master clocks to solve that.
Okay. Look, I mean, I've got a bunch of questions, but we're not going to get to them today. Perhaps we'll do that later online in a written piece. But David, that is fantastic. What a great presentation. Thank you so much. And without further ado, I am to hand over to my colleague, Catherine, who has a fireside chat with XCOM RAN, Global Star, to talk about software-defined 5G and how to bridge the IT-OT gap. But from David and me, that's all for now. Thank you.
Thank you.